Okay, now I just want to talk about descriptive statistics briefly. Tableau is really not a good tool for doing standard descriptive statistics. What do I mean with standard? Let's say you just want a table with the mean, median, maybe minimum value, a maximum value, and so on. So very standard statistics for each variable in your data set. This I would not do in Tableau. This is not what it is meant for. As simple as that. It is really meant for data exploration and visualization, meaning that you try to get a point across using your data. So for this reason, in this video, I will also use Gretl just to show you that the standard descriptive functions are easier to use in Gretl than they are to use in Tableau. However, some descriptive statistics can also be done in Tableau. Obviously, these are all of these descriptive statistics that have to do with visualization. I have loaded a dataset, a country dataset, into Tableau already, and I will click on my first sheet, which opens up this familiar window. Let's say, first of all, I wanted to have an overview of the distribution of a variable. That is something that Tableau can obviously do because when we look at distributions, we usually do that by looking at a histogram. We could now take some variable here from our measures. Let's say we take a GDP variable, GDP per capita, for example. And I just drop it somewhere in the field, or I drop it up here. Usually I drop it up here into rows. By clicking on Show Me in the upper right corner, Tableau already suggests we can build in a histogram out of that data. If I click this, you can see the result. So what has happened? Tableau automatically generates a set of bins, which are categories, across the value of the GDP variable. And it tells you how many values are in each of these categories, okay? The frequency of values in relation to the actual values of the underlying variable. A few things that we can see right away here with this histogram is that we have a few outliers maybe. We have one value which is to the right, a value which is kind of in the middle here, and then some values here, and the bulk of the data really is down here at the lowest bin. This is a typical thing that we might see in GDP data. Now, to get an idea of what these outliers are, we can take our country names, which we have as a dimension here, and we can drop it onto tooltips. By doing this, Tableau now shows you a tooltip when hovering over one of these bins. And the tooltip now reads the country name if it is one country. And in this case, we can see that Luxembourg is one of the outliers with an astronomical GDP per capita, which we all know. And then followed by Norway, which is also really an outlier. But as we go here, you see that country name is a star because we have a lot of countries in this. So we have 91 countries in this bin, and it's not showing us these. If we wanted to see these, we have to do this slightly different. One way to do this is to simply go with the country names and also use them for detail. This just tells Tableau we want some details about the countries, and it transforms the histogram so that when you hover over this bar, it really shows you the underlying countries. Another option would be to get rid of that again and right-click the first bar, which we're interested in, and click Create Set out of this bar. And we can name this set lowest bin, whatever, of GDP per capita. And you see down in the left corner, it has created this new set. If we now create a new worksheet and use the lowest bin as a filter, we can tell Tableau that we only want to include the variables which are in this set. We then go with the country names. We will get only those countries which are actually in this lowest set. Now you can do a few other things with Tableau as well. Let's create a new worksheet, and let's say we wanted to have a box plot to see if there are outliers now. So we put the variable into the row field, and we click this little arrow. The thing is, whenever you put a variable here, it will give you the sum, which is a measure. You have some other options of measures, but all of these measures are somehow aggregates or calculations of the underlying data. If we want the data itself, we select dimension. And by selecting this, you already see that we now get the single data points of this data set. And we can use whatever type of signifier we want. Of course, a line is not really going to work very well. So a Gantt bar in this looks quite nice. And then we can go to analytics and say we wanted a box plot and just drag this into our graph here. And here you have some settings if you want to change some of those, for example, the color to make it more visible. And we click OK. And you can see down here, it has now drawn us a box plot. Up here is the upper whisker. And for this variable, we see that there are a lot of values above the whisker. Once again, you can go to data, use country names for the tooltip, hover over these and see what they are. And all of these countries are in some sense outliers, more than 1.5 times the interquartile range above the highest whisker. Now, these could therefore become influential variables and so on. And maybe you think of a log transformation in order to get rid of this. And we will actually do this in a second. We can also do this for another variable just to see some differences. Let's do it for the ECI variable. And again, go into dimensions and to analytics, pull in the box plot. And what we see now is that here we really do not have an outlier. So we have, again, some countries which are on the edge. For tooltip is country name, and we take a look at Guinea, which is kind of on the whisker, and here on the whisker is Japan. But really, we have nothing that sticks out completely. So we are a little bit more confident that we would not have to adjust the data here because it really doesn't pose any problems. One of the strongest suits, so to say, of Tableau is to find relationships between variables. Let's once again take something like GDP, but this time in absolute terms, not per capita. And we put this into 2 rows. And we will use FDI SA, which is the absolute values of FDI stock of a country. Again, we change these sum fields into dimensions so that we see the individual data and we get a scatter plot. So this is how you create a scatter plot very simply in Tableau. Now, we know that we can now look at the correlation to see how well these two variables match. The way to do this is either you right-click and you click on trend lines and show trend lines, or you go to analytics here and you take the trend line function and you pull it into one of those fields. We're now going to use the linear trend line. You can show other trends in the data as well, but we're going to show the linear one for now. This is giving you this line. When you hover over the line, it gives you some details already. And if you right-click on the line and you say describe trend model, it shows you a full small regression model. It is basically, of course, this line that is shown is the result of a linear regression of 2 variables, right? Whenever you actually see a line calculated, it means that there is a regression process behind this. How can we now find out the correlation? Because let's say we're interested in the correlation coefficient between those 2 variables. Well, it gives us here r squared. And in a simple linear regression with 2 variables, the r squared is simply the squared correlation coefficient. So 0.33, if we take the square root of that, we get the correlation. So you could simply say 0.33 into a calculator, take the square root, and 0.57 here is the correlation. Now you remember probably that we can transform such data as here with a logarithmic transformation. Why? Well, because we have some outlying variables and a lot of distance between the data points in this graph up here. And down here, everything is very close together so that we don't really see everything, right? In order to fix this problem, we can calculate a logarithm within Tableau. To do that, you just right-click below Measures and you say Create a Calculated Field. And we just call this log FDI. And in this field, you can type whatever you want. You can calculate with variables. For now, I'm just going to calculate the log of the FDI variable we're using. If you type in L and O, it already suggests to you the right function that you're looking for. So it has a catalog of functions that it suggests. We can click log, And it now tells us, just like Excel, what it needs. We need a number for the lock, and with number it means a variable that should be locked, and a base of the lock. For the variable, we have to start with a bracket. Okay, we open it and just type F, and it automatically shows me here my FDI variables, and I take the FDI as A. And don't even have to close the bracket, it does that automatically. And now I say comma, and for the base, I pick 10. And I click OK. Now here we see I've created a new variable called lock FDI. I can do this for GDP as well. So GDP absolute, and the base is 10. We close the parenthesis. We have this variable in here. Click OK. And now we do another sheet, and we look at the scatter plot of these locked values now. Again, switch to dimensions. And here you see a totally different scatter plot, right? You see how what we've done is we've reduced the distance between those data points, brought them closer together here, and we have slightly, in that sense, increased the distance of these data points down here so that we have a better picture on all of this. One tendency of the lock is that small values will be exaggerated in the end product. So we have one outlier which is really has some very small values for both of these variables. If we now go back and calculate a trend line, what you see is, I hope you see, that this trend line looks a little bit better. And if we describe the trend model, we can now see an R-squared of 0.81. And if we would want to plug that into a calculator, we would get something like a 0.9 correlation. So the correlation has gotten stronger. This is one of the things that can sometimes happen when you lock variables. Actually, you can improve their correlation. Whether this is a meaningful correlation, once again, depends on your interpretation of what you're doing there, why you're doing that, and really what the underlying theory is. Why should GDP and FDI have a positive relationship that is fairly strong, right? If there's a good case for this, maybe you would say that this is really a better view at the data. Let me now briefly show you how to do similar things in Gretls. So this is the Gretl main menu, and as you see, I've loaded the same dataset with the same types of variables in here. When we want to know descriptive statistics, it's pretty much enough to right-click on a variable. And here you can click Summary Statistics, and this gives you just the mean, median, minimum, maximum standard deviation, and some additional values. Also, it gives you the missing observations, which could be interesting, how much of your data is missing in that variable. So much quicker than you could ever do in Tableau. Another thing you could do here as well is to generate a box plot. Of course, this looks ugly because this is GDP in absolute terms. This has a lot of outliers. And in general, the graphs are not as nice as in Tableau, but they are functional, of course, functionally equivalent. And you can also do histograms here and so on. Now, one of the things I can show you is that you can quickly create locks as well. We had the GDP absolute variable, and we can just right-click and say add a lock. And it will tell you that we generated missing values, which is normal because we had some zero values, or actually missing values, depends. And then we here have the FDI stock, and we also click add locks. And if we scroll down, we can see we've created two new variables of the logarithms of these variables, right? Now, if we click View, we have the option to calculate a correlation matrix. And we use now the logs of these two variables. And we also use their original selves, untransformed. Click OK. So this is the result of the calculation of the correlation. And as we can see, it is actually the same as we have just determined by our calculation. So of the R-squared in Tableau. So the log GDP in absolute terms and the log FDI in absolute stock in absolute terms has a correlation of 0.9. And this is just what I said. If you take the square root of 0.8, you kind of get a 0.9. The other thing that we've done is we have correlated in Tableau FDI stock absolute, and GDP absolute untransformed. And for the untransformed variables, we get a 0.57, which was exactly what we've calculated based on the 0.33 output of the R-square in Tableau. So this is how basically the correlation coefficient that you see here, the Pearson correlation coefficient, relates to the R-square that is displayed in a simple linear regression with one dependent variable and an independent variable and an intercept.